Okay, so now we're going to look at the identities for the tangent and the inverse tangent function. And just like for sine, we've got that the inverse tangent of tangent x is equal to x if x is between negative pi over 2 and positive pi over 2. And the tangent of inverse tangent of x is always equal to x. So there's no limit on what x can be here. Okay, so next we're going to take a look at finding the inverse tangent of the tangent of pi over 4. And we're lucky here, so since negative pi over 4 is between negative pi over 2 and pi over 2, we can use the identity. And so this is just equal to negative pi over 4. Okay, next we're going to have the definition for the other three inverse functions. First up is the inverse cotangent function. So if y is equal to inverse cotangent of x, or you could say y equals arc cotangent x, those mean the same thing. That means x is equal to the cotangent of y, and y is between 0 and pi. So this is similar to the inverse cosine. And then next, we have the inverse secant function, or arc secant. So if y is equal to inverse secant x, that means that x is equal to the secant of y, where y is between 0 and pi over 2, or y is between pi over 2 and pi. You might wonder why I split it up like that. The reason is y can't equal pi over 2. And that's because that would cause me to divide by 0. Right? And as far as what x can be less than negative 1, or x is greater than 1. So over here, I'm going to go ahead and be more explicit. I'm going to say that y is greater than or equal to 0, but less than pi over 2, or y is greater than pi over 2, but less than or equal to pi. And then the last we have is our inverse cosecant function. So y equals inverse cosecant x, or arc cosecant x. That means that x is equal to the cosecant of y. And I'm going to go ahead and put down the restrictions for x first. X can be less than negative 1, or x is greater than 1, just like with the inverse secant function. And then for y is greater than or equal to negative pi over 2, but less than 0, or y is greater than 0, but less than or equal to pi over 2. Okay? So the inverse secant essentially goes from 0 to pi, except it can't be pi over 2. So this one is similar to arc cosine. And then for inverse cosecant, it's essentially going from negative pi over 2 to positive pi over 2, except it can't equal 0. So it's similar to inverse sine. Okay, we're going to take a look at a few examples. We want to first find inverse cosecant of the square root of 2. So I'm going to say that's equal to y, where the cosecant of y is equal to the square root of 2. And y is, well, in this case, we want it to be between negative pi over 2 and pi over 2, but not equal to 0. Okay, and then we need to think what angle y has the cosecant equal to the square root of 2. So that means that 1 over the sine of y is equal to the square root of 2. And so that means that the sine of y is equal to 1 over the square root of 2. Or, in other words, the square root of 2 over 2. And the value of y that works there is pi over 4. Since the sine of pi over 4 is equal to the square root of 2 over 2, and pi over 4 is between negative pi over 2 and pi over 2, that tells me that the answer up here is pi over 4. Next, we're going to take a look at the arc secant of negative 2. So I'm going to say that's equal to y, where the secant of y is equal to negative 2, and y is between 0 and pi, but not equal to pi over 2. So we have 1 over the cosine of y is equal to negative 2. That's because the secant function is equal to 1 over the cosine function. So I'm going to solve for cosine y. This gives me cosine of y is equal to negative 1/2. And since the cosine of 2 pi over 3 is equal to negative 1/2, and 2 pi over 3 is between 0 and pi, that tells me that the answer to this problem is 2 pi over 3. Next, we're going to take a look at finding the inverse cotangent of negative square root 3 over 3. So I'm going to say this is equal to y, where cotangent of y is equal to negative square root of 3 over 3, and y is between 0 and pi. Okay, and the angle that makes that work, since the cotangent of 2 pi over 3 is equal to negative square root 3 over 3, and 2 pi over 3 is between 0 and I. That tells me that the answer to this one is 2 pi over 3. Anybody have any questions so far? Okay. So next, we want to figure out the exact value of the tangent of the arc cosine of 2/3. So we're going to let theta equal the arc cosine of 2/3. According to the definition of the arc cosine function, theta has to be in which quadrant? Well, let's see. So I know theta must be between 0 and pi. So that means theta is either in quadrant 1 or in quadrant 2. And since the cosine of theta is positive, theta has to be in quadrant number 1. Make sense so far? Okay, I'm going to stop the recording for just a minute.